Alright, so I have a question, 1.1, number 17, which says, is the relationship y equals x to the fourth minus 1 a function y of x, or x of y, or neither, or both? You guys with me on this idea?
It's a mouthful.
Okay, first things first. If you put in an x, do you get a predictable result for y?
Yes.
Yeah.
You guys see that? Yes?
Mm-hmm.
Yes?
Yes.
Yes! That sounds like this is in fact a function. You guys see that? Right? That's x's are the inputs, y's are the outputs, and it's not a gumball machine. Always get the same thing. You guys with me on that? Okay. That means the answer is definitely not neither. Right? Because at least this one's a function. Okay. Is x a function of y? In other words, if I put a y in, do I get a unique x out?
Yeah.
No.
Sure.
I thought you could, if you put a y in, solve for x. I thought that's what you were saying.
Okay, yeah, let's try that. Let's put a y in. What's the easiest y to try?
0.
0. Good man. Thank you, Jeff.
You're welcome.
So 0 is x to the fourth minus 1, right? Keep in mind, even if this works, I still wouldn't know for sure, right? Because I just tried one y. It might be that some y's give you unique x's, but others don't. But this isn't going to work anyway.
Oh, is it because it's to the fourth, and so you can get a plus or a minus?
Yep.
That makes sense.
So to solve this, right, you would do add 1 to both sides, right?
Yeah.
This notation is probably new for you guys. Is that true? So this is just me saying this is the thing I'm doing to both sides, right? Or this is the step I'm applying. In pre-calc, sometimes I'll write like arrow algebra, right, for a couple of steps of algebra. But we're warming up, so one step at a time. So I got 1 is x to the fourth, right? You guys all see that? Okay. What can I multiply by itself 4 times and get 1 out?
1 and negative.
Yeah, either 1 or negative 1. Yeah, and that makes it not a function. You guys see that? Because that was 1 input, 0, went to 2 outputs.
And it fails the vertical line test.
Yeah, so another thing that I didn't give you guys the other day is this thing called a vertical line test.
We looked at that.
So let's get that down. Can anybody state the vertical line test?
I don't know, we don't
Vertical
actually know
line.
the concept.
Okay, you know the concept, but not the. Why are you raising your hands? Just talk.
You take a vertical line, and if you go across a graph, if it meets 2 points on that line, then it's not.
Good. You guys with that? So I would take a vertical line, right? A line for one of the inputs, sweep it across, and see if I ever find 2 outputs that go with that input. You guys see that? So that would be, right, if a vertical line, i.e. x equals number, right? I think that's what the equation of a vertical line looks like. Intersects a graph, and I'm using the word graph here kind of loosely, because this thing, if it fails the vertical line test, it isn't a graph. You guys see that? Like a graph goes with a function. So if something fails a vertical line test, it's not a graph of a function. So what I mean here is really like a potential graph, right?
You just put that.
I could just put that, so why don't I? So I have a potential graph, and if my vertical line intersects a potential graph, what?
More than one.
More than once. Then what?
It's not a function.
It's not a function. The graph is not a graph.
The graph is not a
right? I.e.,
A whole life is a lie.
there isn't a function with that
Graph.
as a graph.
I really should put the graph next.
Oh,
Yeah, really we should call it a graph test. That would be better. You guys all with me on that? So let me apply that thing to this object, right? So here I was looking at y is x to the fourth minus 1. Can you guys graph that?
Yeah, good. So,
Yeah, that,
I mean, what is the dumbest method by which you could graph
yeah.
this?
Done.
Yeah, you plug some numbers in, right? See what they give you, plot the points, and connect the dots, right?
make a chart table.
Yeah, make a table and then plot the points and connect dots.
Maybe find a graphing calculator.
Or you can find a graphing calculator, or you could know that x to the fourth looks like, yeah, it looks kind of like a parabola. And then the minus 1 shifts it
Left.
down 1. So, wherever you get a graph from, you're going to get a graph that looks like this. You guys see this? In X land, right, where X's are the inputs, I'm sweeping a vertical line, right? You guys see that? Does it ever intersect more than once?
No.
Nope. So, y is a function of x. Now, it's going to get a little weird because now I'm going to make a vertical line for y's. Right? So I'm going to peg y equals something, and that's going to look like this. You guys see that?
Mhm.
Really, that's me doing the horizontal line test, right?
Yeah.
That's me checking if there's an inverse function for this thing. There isn't. Right? Because it hits more than once. You guys see that? You remember the horizontal line test too?
Exactly.
Yeah?
No.
Okay, we'll get there more when we do inverse functions. But for right now, you could redraw this picture, right? Where instead of x and y, you had y's and x's, right?
Yeah. Makes sense.
You guys see that?
Yeah.
And then this would look like this kind of a picture. And it would fail the vertical line test because of a vertical line like this guy. You guys cool with that? Why? What about a vertical line like over here?
I mean, it's just not really on your data set.
Yeah, like sometimes that's fine. You guys see that? Like a vertical line can hit no times. That's not more than once.
Yeah.
You guys see that?
Yeah.
It's possible for it to hit lots of different amounts of times depending on where you put the vertical line, right? All you need is more than once somewhere, and it's not the graph of a function. You guys cool with that?